Hey everybody, we are back. We're talking about solving quadratics by factoring. Now keep in mind, solving quadratics indicates that we're not just graphing, we are setting it equal to something and solving for a value. So let's talk about some key terms. So a monomial is an expression that is either a number, that's a number, a variable, or the product of a number and one or more variables. So this could be like the number 2 and letter x, or 2x squared, things like that. A binomial, this indicates 2, is two values such as where we have the sum of two monomials. And a trinomial is the sum of three monomials. So what else is a monomial? So let's talk about what's a monomial really quick. Okay, so let's make a box right here. Here's what a monomial is. It can be x, it can be 2x, it can be 2x squared, it can be xy, it could be x squared y, it could be 3x squared y. It could also have something like 1/3 x or negative 2x, things like that, okay? Where we have a variable or a number times a variable or several variables. What it cannot be something with a variable in the denominator, okay? This cannot be a monomial. It cannot be something with a variable in the exponent. So like if you've got x to the y, that's not a monomial. It's also not anything with a variable in the denominator, okay? So these are examples up here where these are monomials, these are not monomials. Okay, so let's keep going. So let's talk about, remember when we had two binomials that looked like this, and if I had to FOIL these, we took x times x as the first terms, we get x squared. Outside terms, so that's x times n is nx plus mx plus whatever m times n is. Keep in mind these are like terms, so we could combine those two, right? So just like we can work those, and this would become x squared equals, or I shouldn't say equals, x squared plus whatever n plus m is, we do usually call that bx plus, and this value would be some number or letter, number c. So if you've got standard form, remember this looks like standard form of a quadratic, I can break that up and I can say, well, I know this means that if I've got ax squared plus bx plus c, I can break that up into x times x plus two numbers, I don't know what they are, times each other, and that we can say that this is going to become x squared plus, remember that middle term, we call that b, or we can say that that's really just m plus n, whatever that is, times x plus m times n. So these two numbers have a relationship that we call factoring. So before we can start to factor trinomials in this form, we need to talk about what that looks like. So keep in mind, if I see a trinomial in this form, x squared plus bx plus c, remember that is in standard form, but instead of the value of a being any number, this form has this invisible 1 in the front. So we have 1 x squared plus bx plus c. So this is when A is 1. So go ahead and turn over to the back page. And what we're going to do is we're going to learn we're going to use this paper to factor any polynomial over the course of this chapter. But first thing we're going to do is we're going to look at what happens when it's a trinomial, because remember, trinomial means 3 parts, so 1, 2, 3. That's a trinomial, 3 monomials. And the A value out front here in front of the X is a 1. So here's how to factor polynomials. We're always going to check for a greatest common factor first. So maybe if all of the coefficients have a factor of 2, you can take that out. You're going to look to see, can we divide anything into all of the terms first? The second thing we're always going to look at, so after the first step is the GCF, the second step is we're going to look at the number of terms. So in this case, because we're looking how to factor x squared plus bx plus c, there's 3 terms there. So we're going to look right here. The second thing we're going to look at is what's the value of a? Well, in this case, this value of a is 1. So we're going to look over here and look at that. This is the case when our a value is 1. So we're going to learn how to factor a trinomial where a is 1. This is called what I call x factor. Okay? So remember that when we have this x factor, it looks like x squared plus x squared plus bx plus c. Keep in mind, we have that invisible 1 in front here. So here's where that x factor comes in. We're going to draw a great big X, okay? We're going to put the value of c up top and the b value on the bottom. Now, we're going to look for 2 numbers. We'll call them m and n that will multiply to c but add to b. Once we figure that out, whatever these 2 numbers are, we're going to put that into 2 parentheses. So then we're going to put those into 2 parentheses. We know x squared can be written as x times x. And then whatever the m is, we're going to put that right here. And whenever n is, we put it here. So we plug these in here. And that would be in factored form. Okay, so go ahead and draw a line right here. Let's do an example. So if I had x squared plus 5x plus 4, okay? So first thing I'm going to do is I'm going to draw a big X. And I recognize here that this value is the b value and this is the c value. So I'm going to put the c on the top and the b value of 5 on the bottom. Okay, I'm going to scroll in here. So my next step is I need to figure out what factors of 4 will multiply to 4 and what 2 numbers will add to 5. So what 2 numbers will multiply to 4 and add to 5? Well, let's think. The factors of 4 are 2 and 2, but 2 and 2 will multiply to 4 but not add to 5. Okay. Another case is 2 factors of 4 are 1 and 4. Will 1 and 4 add to 5? Yes, they will. So I'm going to put 1 and 4 here. This is our m value, and this is our n value. So once I have m and n, I'm going to plug these in here. I know x squared comes from x times x, and then I'm going to put m here, which is 1, and n is 4 here. So if I were to FOIL that back out, I would get back to this original equation. Okay? So let's use what we just learned about factoring a trinomial with the a value of 1 using our process called x factor. And let's use that in our example, okay? So our x factor, here we go. We know first things first, we need to double check we've got 1, 2, 3 terms here. We know it's a trinomial. And if we look here, this value in front of the x squared is 1. So we're going to use that x factor. So here's my big X. I'm going to put the value of c on the top and the value of b on the bottom. So now I have to think, okay, what will multiply to 20 and add to -9? So what are the factors of 20? Let's think about that. Well, I know 1 and 20. Can 1 and 20 add or subtract to a 9? Nope. So we're going to cross that one out. What's another factor of 20? So how about 2 and 10? Can 2 and 10 add or subtract to a negative 9? Nope. How about 3? 3 doesn't go into 20. How about 4 and 5? Okay, can 4 and 5 somehow make a 9? Yes, they can. So let's put a 4 and a 5 here. Now keep in mind, this is a positive 20, but this is a negative 9. So in order to multiply to a positive, they either both need to be positive or they both need to be negative. In order to add to a negative, it looks like they're going to both have to be negative. So let's check this. Does negative 4 and negative 5 multiply to 20? Yes. Does negative 4 and negative 5 add to negative 9? Yes. So let's plug this in now. So in our factors, we know x squared comes from x times x. And now we're going to put this negative 4 right here. And negative 5 goes right here. And that is our factored form. Okay. The next thing we're going to learn is, okay, we've got a quadratic, but instead of 3 parts, there's 1, 2 parts. So let's go back over to the other side and let's look to see what would happen if we're learning how to factor a number of terms where there's 2 terms. And for right now, the only way that we can factor something that's 2 terms, if it is this circumstance of a difference, remember the word difference in math is subtraction, of 2 squares. So for example, the only way this is going to work is if I look back up here and I look to see, okay, is x squared a perfect square? Yes, it is. Is 9 a perfect square? It is as well. 9 is the equivalent of 3 squared. So we can use this method that we're about to learn. Okay, so let's go over here. So here's how we're going to factor a 2-term or a binomial difference of 2 squares. We use what's called a difference of 2 squares. I use DOTS. That's the dots method. Okay, the dots method is as simple as this. So if I've got x squared minus some value of a perfect squared, a squared, here's how we set this up. It's as simple as this. We take x squared comes from x times x. A squared comes from a times a. 1 is a plus and 1 is a minus. That's it. That is how we factor. So for example, let's put this one in here. If I have x squared minus 16, I know there's 2 terms, a difference, and 2 perfect squares. So what we're going to do now is come back, set up the factors. We know x squared comes from x times x. 16 comes from 4 times 4. And because there's a difference in the middle, we know that 1's a plus and 1 is a minus. If I were to FOIL this again, I would come right back to x squared minus 16. So let's use that process that we just wrote down to solve this. So what if I've got a quadratic of 2 terms, there's a difference, and they're both squares. So we use our DOTS system of factoring for difference of 2 squares. I know in order to do difference of 2 squares, I have to take this. Well, x squared comes from x times x. 9 comes from 3 times 3. And because there's that difference in the middle, I can say, well, I know 1's a plus and 1's a minus. If I were to check this in FOIL again, I could go checking it. X times x is x squared. X times negative 3 is negative 3x. X times 3 is positive 3x. And x times negative 3 is 9. We know negative 3 and positive 3 cancel, so we're left with x squared minus 9. So do you see how it comes back full circle? That this really is the factor of our difference of 2 squares binomial. All right, guys, that's all we're going to do today. I'll see you back in